We want to find the coordinates of the turning points on the curve y is 3x minus 4 cubed times 2x plus 3 squared. So y is 3x minus 4 cubed times 2x plus 3 squared. And we have a product. Let u be 3x minus 4 all cubed and v be 2x plus 3 all squared. We need du dx, differentiate using the chain rule, differentiate the bracket, and multiply by the differential of the inside. This gives us 9 times 3x minus 4 squared. We need the chain rule for dv dx as well. Differentiate the bracket as if it's just an x, and multiply by the differential of the inside. This tidies to 4 times 2x plus 3. Now dy dx is equal to v times du dx, which is 9 times 3x minus 4 squared times 2x plus 3 squared, added to u times dv dx, which is 4 times 2x plus 3 times 3x minus 4 cubed. For turning points, we do need to tidy this. If we look for common factors, we can see that 2x plus 3 is a common factor. 3x minus 4 squared is a common factor. And what we have left is a 9 and a 2x plus 3. And in the second term, a 4 and a 3x take away 4. So we have 2x plus 3, 3x minus 4 squared, and this is 18x plus 12x, which is 30x, and 27, take away 16, which is 11. We want turning points, and that means dy dx is equal to 0. So we need to have this equal to 0. 2x plus 3 times 3x minus 4 squared times 30x plus 11 is equal to 0. We can see this gives us x is minus 3 over 2. This gives us x is 4 over 3. And the final bracket gives us that x is minus 11 over 30. We want coordinates, so we need corresponding y values. If x is minus 3 over 2, the second bracket would become 0. So the whole expression will become 0, and y is equal to 0. If x is 4 over 3, this would make the first bracket 0, and therefore once again y would be 0. Now if x is minus 11 over 30, we need to substitute in. So we get 3 times minus 11 over 30, take away 4, cubed, multiplied by 2 times minus 11 over 30 plus 3 squared. This calculates to give minus 682, correct to 3 significant figures. So we have minus 11 over 30 minus 682. Although, of course, you could have given this last answer as an exact fraction. So here we have the coordinates of our three turning points.